Hey guys, welcome back to another lesson. Today we're going to talk about analyzing graphs of polynomial functions, okay? And some of this is a review of the previous lesson, but we're just going to add to it, okay? I do have these graphs already set, so we'll get through the graphing part rather quickly. I'd encourage you to pause the video so you can graph it yourself. Just do a nice little rough sketch, okay? So let's take a look at our very first function. We have here negative x cubed minus 4x squared plus 5. Now, let's just think about this in general, what this could look like before we actually graph it, and kind of discuss what we're seeing. I can tell that by the leading degree, that x cubed, that's an odd degree function. Okay, so that's one thing I can pick up. And because it's odd degree, that means that the endpoints are going to be pointing in different directions. Now, typically, the endpoints would point in this direction, okay? Because the negative's there, it's being reflected. So realistically, it's going to go in the other direction, okay? So that's one thing I can think about with this graph. Another thing, okay, we talked about the number of zeros. Because this is a cubed function, it's going to have an odd number of zeros, okay? Now, we'll talk a little bit more in terms of what's the maximum number it could have. That's further down along the line, okay? And I think that's about it that we can discuss. So let's go ahead and fill out an XY table, okay? And we're going to go from -4 to 2. We're going to use that range. And when we plug these values into this function, and like I said, I'm saving time. I'm not going to plug each number in and evaluate. This video would take a long time to make. All right, so looking at this, we would get 5, -4, -3, 2, 5, 0, and -19. Okay? So those are my points. Sorry about that. Make that a little bit more prominent. So now what I'm going to do is I'm going to graph it on here. Okay? So let me go ahead and do that real quick. Let's see. -4, 5, -3, -4, -2, -3, Okay, so there's the points. And I know that the function endpoints are going to look like this. So it's going to start like this on the left-hand side. Okay, so I'm going to come down. All right, and then to get to this point, it's going to cross the x-axis, right? So here we go, crosses the x-axis. Connects it to this point, so it's going to curve upward a little bit. Cross the x-axis again. Okay, reach a point, like another high maximum value here, it looks like. Comes down, intersects the x-axis again. Okay, and as you can see, when it gets to this point, I know what it's going to look like anyway, because remember, the end behavior is it's going to point downward infinitely. That's the behavior of an odd function. So here it is. There's my graph. Okay. Now, let's make some observations here. Look at the table for a second. I can see that we were going to have 3 zeros. Okay, so 3 is an odd number. All right, that's good. That's what we expected. But let's look at the table, though. Could we figure out where the zeros might be looking at just the table? Notice something. I'm going to use a different color here. Okay. Right here, f of x is positive, right? That's a positive y value. Now, when it crosses the x-axis, the f(x) value, or my y value, becomes negative. Okay? Now, hold on one second, sorry. I'm just recording, so you're fine. Okay. So because the sign changed, it's going to intersect here on the x-axis. All right? Now let's look at the table and see if we can't figure that out as well. We'll go from +5 to -4. So right here, I can tell that, hey, there's going to be a 0. Now remember, 0 means there's a solution somewhere. It's hitting the x-axis. Okay? Now over here, notice, f of x becomes negative again, and then it changes to a positive value. Okay? So let's look at the table And I can see that it goes from -3 to 2, right around this position, right? A -2, -1. Okay? So that's another place where I have a 0. And then over here, I can see the same thing happening. My y value is positive, and then my y value becomes negative. And that's going to be down here. So here's another 0 then. Okay? In fact, the 0 is 1, 0, huh? Ironically, it's going to be that point. But if it wasn't exactly there, I could still say it's going to be between two values. So my zeros are located between the x values of -4, -3, -2, -1, and then this one is actually a 0 value there. Okay? So knowing where the signs changed tells us where the solutions are to this grid. And we could see that by a table. Now this entire process, locating the zeros like this, it's called the location principle. Okay? So the location principle, sorry, I spelled principle wrong. Okay, the location principle states that wherever there is a sign change, okay, for the y values, there is at least 1 0 located between that change. Okay? At least one. And in the examples we're going to be doing, we're going to see just one solution between those sign changes. Okay? So that's called the location principle. Make sense? All right. Let's go ahead and graph another one and see if we can't locate the zeros. And then we're going to graph it to see if we were correct. All right? So here's my next one. I'm going to try out here. Okay? And I highly encourage you, pause the video. Okay, see if you can't get these answers. And just make sure, yeah, okay. Sorry about that. Let me go ahead and plug in these values. So if you plug in -2, you get a 9. -1, 1, -3, -7, and 19. Okay. Now let's make the same analysis here. All right. This is an even degree polynomial, which means that the endpoints are going to both be pointing upward or downward. Because there's no negative, they're both going to be pointing upward. Okay? There's going to be an even number of zeros. If I'm looking at my table, I need to see if there's going to be an even number. And there should be, and we'll see shortly. Okay? So let's go ahead and locate the zeros. And remember, that's where the sign changes. So at the very beginning, notice how it goes from 9 to -1. Okay, so that means between the x values, -2, -1, I have a 0. Okay, so there's 1 0 there. In fact, do I have... Oh, there it is. I'll do it a different color. Use my blue marker. There's a 0 there. Okay, let's locate another one. So look how it goes from 1 to a -3. So right here is another 0. So between the x values, 0 and 1, there's another solution. And do we see another one here? I think we do, huh? There's another sign change. And it's going to be here. Okay? -7 to +19. And guess what? I missed another one. -1 to 1. There's another 0 here. Okay? So there's a total of 4 zeros. That means, okay, I'm going to have 4 intercepts on this graph. Now, we have 4 zeros, even number of zeros, good. Okay, that checks out. That's what we know about even degree polynomials. Okay, let's go ahead and graph the points here. And once again, rough sketch, just to give us an idea of what this looks like. So -2, 9, we could say is up here. -1, 1. I'm sorry, -1, -1. Let's see, 0, 1, 1, -3, 2, -7, and then 3, 19. There we go. So there's my points. Now, how am I going to draw this? That's the next question. Well, remember, it's even degree, and the endpoints are going to be pointing upward. So I'm not going to come this way. I'm actually going to come down this way, right? So I'm going to hit the first point, Okay, I'm going to come down here, hit my next point. Then I'm going to come back up to hit this guy. Then I'm going to come back down, cross the x-axis again to connect the bottom 2 points here. And I'm going to shoot all the way up here. There's another point that's coming up past the x-axis all the way up here. That's 319. That's the point over there. It looks like a W, right? In a way. Okay. Now, did we do this correctly? There's a 0 located between -2 and -1. -2, -1, there's my first 0. Okay. The table matches the graph so far. There's another 0 between -1 and 0. -1, 0. Yep. That's what we discussed. There's another 0 between 0 and 1. Yep, right here. And then finally, there's another 0 located between 2 and 3. So here's 2 and 3, right? And look, there's another 0. Okay? Now this is a rough sketch, so I don't have the exact values, what makes this guy correct, but I at least know where the locations are approximately. Okay? Yeah, how about that? That's pretty cool, huh? So just based off of a table, we're able to tell what this guy's doing. And knowing what these polynomials are ahead of time, we can determine what the end behavior is going to look like. That's so cool. It really is. We're figuring out what the graph looks like without actually graphing it yet. Now, let's look into the last part of this lesson. So we located zeros, located the sign changes. Now we're going to talk about relative max and min. Okay? So what does that mean? Well, let's go ahead and talk about definition real quick. And this is just a very loose definition. The whole thing is actually on my PowerPoints that you can see. But relative max and min, if there are no nearby points that have a greater or lesser y coordinate. Let's say I have this graph right here. Now notice, left and right, it continues forever. All right? So is there really going to be a max or min value here? No. But if I get rid of these 2 endpoints, and I focus on what's here in the center, the meat of the graph, okay, so to speak, I can see that this guy right here would be a minimum point, okay? The y-coordinate here is less than the y-coordinates that are to the right and left of it, okay? So this could be what? The y value could be 1. Over here, the y value is 2, and then over here could be like 1.5, okay? So this is the lowest y value in this region. So this we would call a relative min. I put R min to abbreviate. Now over here, notice the same thing happening. My y values are increasing, and right here is the maximum y value because after I go past this point, my y values are less than this guy. So this will be the maximum y value in that region. Okay? So we call that a relative max. Now none of these are true max or min because once again, the end behaviors go on to positive and negative infinity. So we can't say that. But if we're just looking at what's here between the endpoints, well, there is a max and min located somewhere hidden here. Okay? Pretty cool, huh? Now, let's go back to the previous example real quick. So looking at this guy, I can tell that right here would be a relative max, and then right here would be a relative min. All right? Now, does the table confirm this? Let's look at the table real quick. Okay? So, right here, this section of the graph is this guy over here. Now, is this y value larger than the y values left and right of it? Yes. And that's what the graph's showing, right? So this could be my relative max. Now let's look at a relative min for a second. That's going to be this guy. Okay? Sorry. All right. -3 is smaller than the values, or not smaller. Oh, I'm sorry, wait a minute. Was I right the first time? Yeah, I was right the first time. My hand started boxing it, and for some reason I stopped. I don't know why. Sorry. It's this guy. There we go. Apologize for that. Negative 7 is less than negative 3 and 19. That here is what this is looking like. So that's going to be my relative min for this graph. Does that make sense? So that's what we're trying to look at here. Relative max and relative min, which is these like humps in a way of the graph, these little hills. Okay? So let's do one more example. And this example is going to be the grand finale. We're going to do everything in this example. Okay? So let's see here. And, okay. All right, so this looks good. So what I'm going to do is I'm going to plug these values into this function and get the y coordinates. And this is what it would be. So we have negative 15, 1, 5, 3, 1, 5, and 21. There we go. Okay. Now I'm not going to graph this yet. I want to discuss all the characteristics this is, and then we'll talk about graphing, okay? Looking at the leading degree, I can see that this is an odd degree polynomial. Oops, I don't know why I put the dash there. Odd degree, okay? Which means that the endpoints are going to be pointing in the opposite direction, so it's going to look like this. Okay? It's going to have an odd number of zeros. We know that for sure. Now let's go ahead and locate those zeros. So let's see. I go from negative 15 to 1. So then that's where one of my zeros would be located. Okay. In fact, let me use the blue marker again. Make it easier to see this. So here we go. There's a 0. All right. Is that it? I think so, huh? Hey, this guy only has 1 0. All the other ones are positive, right? They don't go from positive to negative. So there's 1 0. Now, is that an odd number? Yes. So we match that behavior. Where would the relative max and min be? That's the next question. So let's see what I can find here. Look at the table. Look at the y values for a second. And where would be that relative max and min? I could see right now that, I'm trying to use a different color here. This right here would be a relative max. Okay. Now, why am I saying that? 5 is the largest y value. That's around, what, 1 and 3? That's the largest. But think of it this way. I go from negative 15 to 1. My graph is rising. It's increasing, right? And then it gets to 5. And then it goes to 3. So it stops here at 5, and then it starts decreasing. So that's like the hump of the graph, right? That's the hill that we're getting to. Now look what happens. I'm going to start decreasing, and then, I think I stop right here, huh? Then I start increasing again, huh? So from here down, I'm decreasing, or I'm not decreasing, I'm increasing now. So I'm going from 5 to 21 to, I'm just going to keep going. So right here would be the relative minimum value. Okay, wow, my marker's drying out here, I'm sorry. Relative min. There we go. Perfect. Okay? Because this is the lowest value that's around, what, 3 and 5. So it's going to go downward, or not downward, it's going to go up, reach at 5, go down, reach at 1, and then go all the way up infinitely. Is how this graph's going to look. Does that make sense? Now, some of you might ask, wait a minute, why is negative 15 not on the list? Okay, why is that not a relative min? Great question. If I plug negative 3 in, let me just delete the top part. I think I get negative 49 from what I remember. Okay? So that means from negative 15 to negative 49, I'm still decreasing quite quickly, to be honest with you. So because of that, this truly isn't a relative min, okay? Because it's going with the trend of the graph there. All right? That's a great question to ask because that's something that pops in my mind too. All right, let's graph the points. So negative 2, negative 15 is down here. Let's see, negative 1, 1, 0, 5, 1, 3, 2, 1, then 3, 5, 4, 21. Okay? Once I said, not drawn to scale, but just gives me an idea. The behavior of the graph is going to do this, right? So that means I'll be coming down here to start. I'm going to come all the way up here, okay, to hit this point. Then I'm going to rise all the way up to here. Now notice, this is 0, 5. That's where my max value is. Then it starts decreasing. Look at the y values. So that's what this is going to do. It's going to start decreasing down like this. Then right at this point, look what we discovered. That's the minimum value. Because now, after this, it's going to start increasing. So I'm going to curve this upward, and it's going to go infinitely in that direction. Put that arrow down there. Okay? Here's my relative max, which notice, that's where we did say it was located. Here's my relative minimum value, which, look at that. That's where it's located too. Okay? And we have a 0 located between -2 and -1. Yes, we do. How about that? So everything we discovered here, we showed up here. How about that? That's pretty cool. One final thing I want to note. I just remembered it now. I'm glad I did. I would feel so bad if I didn't include this. Okay. Let's see if I can fit this together. So before we wrap this up, okay, the graph, oh, my blue marker died, guys. It's gone. Hey, I made the basket. Okay. The graph of x to the n power will have n minus 1 turning points. Okay, that's important. So what does that mean? I'm so glad you asked. Look at this guy here. My leading power, I meant to say, is x to the third. So if I take 1 away from that, my graph will have 2 turning points. Let's look at the graph over here now. Okay? I turn, up here once, come down, and then turn here twice. Yep, it had 2 turning points. Let's look at the previous examples. Let's look at this one. Okay? So this is an x to the 4th function. If I take 1 away, I'd have 3 turning points. Well, let's see. Come down here, so this is 1, 2, 3. There's my 3 turning points. Okay? So that's another characteristic that will help us determine if the shape of our graph is correct. By taking the leading power, taking 1 away from it, that'll tell me how many turning points I have here. Okay? That's it. So that's analyzing graphs of polynomials. Most of it is just analyzing the table, and just seeing, what can we see? Because here's what it comes down to. This is the cool part. You have 2 columns of numbers. And based on just 2 columns of numbers, you can tell me what this graph's doing. That's pretty darn incredible, You're developing good graphing techniques here. And we're just going to keep adding to it. So that's the lesson. My notes are online, so you can look at some other examples and try some yourself. But that's it. So until next time, guys, have a good day, and I'll see you all in the next lesson video.